Hey kiddo, I'm glad you're here. Today I'd like to do some math together. We are going to use a number line to add and subtract. And I want to show you a secret about subtraction and how you can subtract by adding. You could also add by subtracting. Everyone has their favorite way, and there are many ways to do it. Some of us feel more successful, more confident with adding, and some of us, our brains just naturally prefer to subtract. And so there are ways that we can do both adding and subtraction with addition or subtraction. I know that seems a little bit weird right now, but I'll show you just what I mean. There are lots of tricks in math. Some people think math is very straightforward. There's a right answer, a wrong answer. It's just numbers. But math is actually kind of individual and creative, and there are many ways of getting an answer, and sometimes many correct answers. These are some things that I love about math. Let's start with some deep breaths. As I think about adding, I think that's adding something new or more that we didn't have before. So I think I'll think of something that has been added to my life that I didn't have before. More of something that I already appreciate, or something new that I appreciate having that I didn't have before. What has been added to your life that you appreciate? I like the addition of a new friend or a new member of family. When my niece or nephew was born, or when I made a new friend, that's a nice addition to my life. Think about something that's been added to your life as you... Okay, I'm not sure if you could hear my dog. He just did a little groan. I'm also very appreciative that my dog was added to my life. I love you, Arthur. Let's think about something that was added to our lives as we take our first breath. And opposite from addition is subtraction. When we subtract, that means something is being given away, or taken away, or removed. And sometimes that can be a nice thing as well. I love giving, whether it's making something for them, or something that they will appreciate that I already have, or looking for the perfect gift to find for them and buy it and give it to them. So I'm thinking of subtraction as giving right now. It's something that I don't have anymore, but it feels nice to give to others. What's something that you like to give, or in other ways remove, subtract from your life that feels better that way? One gift that I like to give to my students is a book that they will enjoy at least once per year, sometimes multiple times per year. I pick out a book for each student that is at their reading level and something that I know will interest them. If they're interested in ponies or superheroes or soccer, I make sure I can find a book that they will enjoy and that is also a good level for them to be able to read. And I write just a short note in there, like their name, and that it's from their teacher, Ms. Nelson, and I hope that that's something that they will continue to enjoy. So I spend the money on it. That money is subtracted, but then the gift is given to them, and that is subtraction. Subtraction is not always a bad thing. It's a part of life, and it's a big part of gift giving. What has been subtracted from your life that feels good to you? Is it giving a gift? Is it getting rid of something that wasn't serving you well? Let's think about that as we take our second breath. And for our third breath, I want you to think of yourself as a mathematician, as a person who can do math. There are many things that might happen in our lives, in school, at work, with our peers. Times when we might feel like we're not so good at something. And there's always going to be someone who is better at it than you. But I don't want you to lose your confidence and think, I can't do it. Or say something like, I'm just not good at math. You can do it. You are a person who can do math. And I like to teach lots of different ways so everyone can find the way that works best for them. So, for our third breath, let's think, I am a mathematician. I am a person who can do math. Let's breathe that in. I'm a person who can do math, and so are you. Let's do some math. I'm going to use a chalkboard today. I have my chalkboard, and it has some lines on it that we will be using as well. I also have a box of chalk, little chalk bits. Adore the sound of chalk. Let's choose this one. I also have a little sponge and a bit of water and a napkin for cleaning. If you have seen another chalk video, you might know why the sponge is so tiny. Okay, we are going to use this line like a number line. Have you used a number line before? On a number line, there are numbers. Going right, the numbers get bigger. Going left, the numbers get smaller. We could start at 1 and then go to 2, 3. What would come next? Yes, 4, 5. Oops. It's a little hard to make small numbers using this chalk. And 6. 7, 8, 9, and 10. A number line goes on and on to make any number you can think of. An open number line is a number line that has arrows on both sides, like this. And that shows that the number line could continue this way, it could continue this way, and we can use whatever part of a number line we want. Like imagine a number line that goes from 0 to 1,000. We could use the part that goes from 95 to 120. We can take whatever slice we want. So, depending on the numbers we're using in our math, we can use any part of a number line we need. We don't always have to start at 0 or 1. It would take a really long time to make a number line that started here if we're using much bigger numbers. So, as the numbers go to the right, they get bigger. As they go to the left, they get smaller. Now I'm going to clear this number line so I can use an open number line and use whatever part I want. I'm going going to use my little sponge and dip it in some water. Wring it out. And unlike when I'm writing and tracing, I'm just going to use this to clear the little marks I've made. And now I can use my napkin to dry it. There we go. I have my open number line. Now I'm going to use this number line to do some adding. I think it's easier to start with adding and then move into subtracting next. So I'm going to make a problem, an addition problem, and we'll see how we can use the number line to solve it. Not just to know it, but also show it. Okay, here we go. I have 5 plus 3 equals, what's the answer? Let's use our number line to solve it. On an open number line, remember, I can start anywhere I want on the number line. I don't have to start at 0 or 1. I'm going to start at my first number this time. I'm going to start at 5. 5. And now I'm going to add 3. If I'm adding, my number will get bigger. So I'm going to move this way as I add. When we go to the right, the numbers get bigger. I'm going to make 3 little hops because I'm going to add 3. 1, 2, 3. Let's find out where I landed. Each hop is just 1 because I did 3. So 5, 6, 7, and 8. We landed on 8. 5 plus 1, 2, 3 equals 8. Now, what if I wanted to add a really big number, like 93? I squeezed that in there. 93 would take a long time to make 93 jumps. We don't have to make jumps of just 1. We can make bigger jumps. Let's clear this and talk about how we can do that. Get some water. Maybe a little more. And dry it. Okay, in numbers, we have something called place value. The value of each place or digit in a number is different. So in the number 3, that means 3 ones. 1, 2, 3. In the number 93, the 3 is still 3 ones. And the next place is the tens. So 93 is 9 tens and 3 ones. In the number 193, we have 3 ones, 9 tens, and 100. Ones, tens, hundreds, thousands would come next. And then 10,000s, 100,000s, millions, and so on. So, if we're adding small numbers, numbers that only have ones, like a 1-digit number, it makes sense to make jumps of 1. But if we're adding a number that has tens in it, we should make hops of 10. I'm not going to do 93 to start. I'll do a smaller one. And then we can work on bigger numbers when we're ready. We'll feel more ready for that after we practice with smaller numbers. we go. Our problem will be my favorite number, 18. That's my lucky number. Do you have a lucky number? Plus 23 equals, let's find out. Okay, remember, open number line, I can start wherever I want. I'm going to start at my first number. When we add, we could start with either one, but 18 is my favorite number, so I'll start with 18. I'm going to put it over here on the left so that I can have plenty of space here to move to the right for my number to get bigger because I'm adding more. Now I'm going to add 23. I'm not going to make 23 little jumps of 1. That would be a long time and a lot of work, and I don't even think I have space for that. Instead, I'm going to make 2 jumps of 10 and 3 jumps of 1. My 10s are going to be a bigger jump. They don't have to be perfect. I'm not a computer, I'm a person. So I will make a jump of 10 and another jump of 10. That's my 2 jumps of 10. I can cross that one out. Sometimes, to be clear, I like to write what I'm adding or subtracting on top. Plus 10. Plus 10. Am I done yet? No. I still have to make 3 jumps of 1. 1, 2, 3. Okay. This is plus 1. Plus 1. Plus 1. Alright. Let's find out where we landed. 18 plus 10. Well, there was one 10 in 18 before, and now we added a 10, so there will be 2 10s. 28. 28 plus 10. There were 2 10s in 28. Now we're adding another 10. That puts us at 38. 38 plus 1. There was 8. One more is 9. 39. 40. 40 plus 1 is 41. There's our answer. 41. So 18 plus 23 equals 41. A number line can be very helpful for adding. We can also use a number line to subtract. When we add, we start way over here and we move to the right because our numbers get bigger when we add. With subtraction, it's the opposite. We have some and then some is taken or given away. So we will have some and then lose some, meaning the number gets smaller. We'll start here and go that way. Time to clean this up. Here we go. We're switching from addition to subtraction. I'm going to start with a larger number and then have some of that number given or taken away. Another way we refer to subtraction is as take away. Let's see, let's start with subtraction, we use a minus sign instead of a plus sign. If you can hear those noisy cars, I apologize. 85 take away or minus 42 equals, let's find out. Remember, we're taking away, the number will get smaller. So we're going to start over on this side of our number line to start. With subtraction, it matters which number we start with. We have this amount, and this amount is being taken away. It's kind of like if I had 5 fingers and I said put down 2 fingers, 1, 2, I can do that. I started with more and I ended with less. If I tried to reverse that and I said I have 2 fingers, now put down 5, oh, I can't do that. That's not possible. So when we're taking away, we always start with the number we have, and then we move or take away the smaller number. Okay, so I have 85. There we go. I'm going to take away 42. Remember, I don't want to spend my time doing 42 little hops, and I don't even have room for that. So I'm going to do 4 jumps of 10 and 2 jumps of 1. Let's go. 1, 2, 3, 4. Each of those jumps was minus 10, or take away 10. And now I need to do 2 jumps of 1. 1, 2. I ended up with just enough space this time. Minus 1, minus 1. Let's see where we ended up. 85 has 8 tens. If I take away one of those tens, then there will only be 7 tens. And the 5 ones are still there. 75. Oh, take away another 10. There are 7. Now there will be 6. And the 5s are still there. The 5 ones are still there. Oh, take away another 10. Now there will be 5 tens and 5 ones. Take away another 10. Now there will be 4 tens and the 5 ones are still there. I took away a 10 each time. And now I'm going to take away ones. There are 5 ones. If I take one away, there will be 4. And if I take another one away, there are 4, and now there will be, oops, let's get a little tight there, 43. Okay, I forgot to cross that off before. 43. There we go. 85 minus 42 equals 43. Now, when we added, we went this way. When we subtracted, we went this way. And now I'm going to teach you a trick that will help you if you're thinking, my brain does much better with adding, or my brain does much better with subtracting. You can switch them up, and maybe not in the way you think. We can't just switch the numbers. That's not going to work. We can't just switch the sign and decide I'm going to do 85 plus 42, because that will not solve the same problem. Here's how we can do it. I'm going to clear my board. And dry. subtract, we're really looking for what's called the difference between two numbers. In fact, the answer to a subtraction problem is called the difference. So if I had my two numbers stacked up next to each other, I would be able to see the difference. I'm going to go back to an easier problem like 5 minus 3. Okay, 5 minus 3. Well, if I had 5, 1, 2, 3, 4, 5, and I had 3, 1, 2, 3. Those are different, aren't they? How different are they? Are they 1 different? Are they 100 different? Well, we can see what's the same. These are the same. These are the same. These are the same. Oh, now we get to the part that's different. The difference is 2. 5 minus 3 equals 2. And we would get the same answer on a number line. If we started with 5 and we took away 3, 1, 2, 3, it would go 4, 3, 2. We get the same answer both ways. So this helps us see how the difference is the same thing as subtracting. We want to know the difference between those two numbers. So, if you prefer to add rather than subtract, you can turn this around to an addition problem. And again, I don't mean making it 5 plus 3. You will not get the same answer. That would be 8. Here's what I do mean. On a number line, you can do something similar to this. You can start at 3 and see how many more it would take to get to 5. So, on my number line, I could start at 3 and see how many more would it be. Oops, this is showing through. It's not plus, it's minus. How many more would it take me to get to 5? 3 is already the same, but I want to know the difference between 3 and 5. Well, let's see. 1 more would be 4. 1 more would be 5. Oops. So, how many did it take me to get to 5? 1, 2. 3 plus 2 equals 5. 5 minus 3 equals 2. You can turn a subtraction problem into an addition problem. Let's try that now with some bigger numbers. Let's do something like 55 minus 19 equals, now remember we could make an open number line, start at 55 and take away 19. 1 jump of 10, 9 jumps of 1. But I'm teaching you the trick right now that we can turn this into an addition problem. This is for those of you who think, my brain just doesn't like subtracting. Counting backwards is a lot harder for me. So, count forward then. What we really want is the difference between these two numbers. The 19 part is the same. 55 is more than 19. So there's, if we imagine them stacked up, there's 19 in both of these. But 55 has a lot more. How many more? We want to know how many more it would take for us to get from 19 up to 55. So from 19, up to 55, up here. How? Sometimes I like to mark it to begin with. If I think I can make the jumps go the right way, it would be around the right size. And sometimes I don't, but I'll try it this time. We want to get from 19 to 55. Let's see, 19. I'm going to make things a little easier on myself. 19 is very close to 20. I think I'm just going to make it 20 because when I start making jumps of 10, it's easier for me to jump from a nice 10 number like 20. So I'm going to add 1. And then I'm at 20. Now, can I make a jump of 100? No, that would be way too big. Could I make a jump of 10? Yeah, I have 2 10s right now, and the number I want to end on has 5 10s. So let's add some 10s. 30, 40, 50. That was plus 10, plus 10, and plus 10. Okay, I'm at 50 and I want to get to 55. I can't make any more jumps of 10 because I already have my 5 10s. And now I need 5 1s. I have 0 right now, so let's add some 1s. Whoops, 51, 52, 53, 54, 55. Plus 1, plus 1, plus 1, plus 1, plus 1. I'm going to have to write really small to fit these. 51, 52, 53, 54, and 55. Now how does this give us the answer? Well, we just found the difference between 19 and 55. We found out how much we would have to add to 19 to get up to 55. It's actually the same thing going backwards. This is 55. If I change each one of these to minus, it goes the other way. So I can just figure out how much this was, and then I know my answer. How many 10s? 1, 2, 3 10s. And how many 1s? 1, 2, 3, 4, 5, 6 1s. My answer was 36. 55 minus 19 equals 36, or 19 plus 36 equals 55. It's a fact family. So, if you are the kind of person who learned addition first, and your brain really loves doing things with addition, you can even do subtraction with addition. You just use the 2 numbers that you know, and you find the difference between them. You can go this way, subtracting, or you can go this way, adding. Your choice. Now, there are some addition problems that you can actually do with subtraction if your brain prefers subtraction. But not all of them work this way. An addition problem that has one part and is missing another part, but it has the whole, can be used for subtraction because the whole number is the part that we would take one of those parts away from. Here's what I mean. If you've ever seen a number bond, it might look something like this. they can look different ways. In a number bond, we have part, part, whole. For example, 6 and 4. 6 plus 4 as the two parts make the whole number of 10. The way we would write that as an equation would be 6 plus 4 equals 10. Now, if we were missing one of these parts, but not the whole, we could do this as a subtraction problem. And here's what I mean. It's called a missing addend. Maybe we're missing this part. Now we have Now we have 6 plus, we don't know, equals 10. What's that missing part? I could add up. I could start at 6 and add up to 10. Or I could go backwards and start with my 10 and take away 6. Both ways would work. So I'm going to move this problem down here. I'll give it a question mark. Equals. And I'll make some space here for my number line. Okay, here I go. Here's my open number line. I can start wherever I want, knowing it continues forever in both directions. Okay, whoops. My napkin's getting pretty wet. It's not drying as well. That's okay. Okay, I think I'll do this 2 different ways. I'll use this one too. On the top, I'll solve this with addition. I know that one part I have is 6, and I want to get to 10. And I want to see how many jumps it'll take to get there. Could I jump 10? No, that would go too far. I need some jumps of 1. 6, 7, 8, 9, 10. Oh, I missed it by a little bit. I'll move my 10 over here. There we go. How many did it take? 1, 2, 3, 4. Let's do it the subtraction way. The whole number is 10. And I'm going to take away one part to figure out what the other part is. I'm going to take away 6. 1, 2, 3, 4, 5, 6. Let's see where I landed. I'm going to count backwards. 10, 9, 8, 7, 6, 5, 4. I landed on 4. So I could do 6 and add 4 to get to 10, or I can do 10 and take away 6, 4, 5, 6 to get to 4. Either way, the missing part is 4. 6 plus 4 equals 10. So some addition problems can be done as subtraction, and those are the types of problems that are missing a part but not missing the whole. Thank you for spending some time doing math with me today. I see math as an opportunity to be creative, solve problems, and figure things out. I love that math can work differently, but also come to the same correct answer. Everyone has their favorite way of doing it, and if you don't have a favorite way yet, let's keep looking. We can find one that works best for you. So, I hope you feel and you believe and you know that you are a person who can do math. Say that with me. I am a person that can do math. You are. Remember, We are all connected. So take care of one